AP Statistics, Chapter 1, Section 2. Cus and BS are a way to describe distribution. C stands for center, U for unusual features, S for shape, second S for spread, B specific is the BS. There are two main ways to describe or measure the center, mean and median. Mean is denoted by x bar, median usually by a capital M. For mean, the formula is the sum of the values over the number of terms. For median, you're going to find the middle term. Usually you count forward or backwards, or there's a formula you will learn later on to describe median. There are two different ways to transform mean and median. But for mean, it's x hat. Your new one is equal to a plus b times your original mean. For the median, it's the same. A plus b times your old median. Next is unusual features. Unusual features includes outliers, terms that are very far away or very far away from your distribution, like shown in this graph. Unusual features also includes multiple peaks in your distribution, like shown in this picture here, and anything else that's not normal or within reasonable bounds. So you can be approximately normal, and that wouldn't be an unusual feature. Shape. Description of the skew of your distribution. There's approximately normal, because none of us can really draw a normal graph, as I can show you here. There's skewed right, where there's a lot of data off to the right of your graph, and skewed left, where there's a lot of data off to the left of your graph. With shape, the XS spread is related. Spread is the description of how the data is distributed within your distribution. You have range, which is largest to smallest, which is not very descriptive and you won't use it often. Then there's two others, IQR, interquartile range, which we'll describe here in a bit, and there's standard deviation, which we will also describe here in a bit. Usually you use IQR or standard deviation, which is also denoted by sigma. Be specific. This is very important while you're taking the AP test. When describing distributions, it's important to keep in mind these following things. Use complete sentences every single time. Talk about on average whenever you're describing distributions or comparing, and be as descriptive as possible. The more descriptive you are, the more points you'll get. Interquartile range. How to describe the spread of a collection of data. Quartiles. Quartile 1 is 25% of the data, so 25% of your numbers are going to be below the value of quartile 1. Quartile 2, 50% of your data is going to be below that number. Quartile 3, 75% of the numbers will be below that one. Note that those are lower. Quartile 2 could also be median. Your entire quartile range is going to be equal to your Q3 or Q1, which is the range of the middle 50% of your data. Your 5-number summary is very important. You'll see a lot of questions that talk about your 5-number summary. The 5 numbers included in it are low, quartile 1, median, quartile 3, and high. It can be used to create a box plot, which is a very important graph. Box plot starts with a line for your lowest value, a line for quartile 1, which is boxed, and then a line on your median, a line for your quartile 3, and a line that extends out to your high value. Often is referred to as a box and whiskers plot. But it's not the only use for your 5-number summary. 5-number summary can also be used or be determined from stem plot. Stem plot very much just looks like it's got stem on the left and your leaves on the right, which just basically describes a bunch of number within a certain range. So there's 13, 14, 17, 22, 24, 25, 25, 26, so on and so forth. Make sure you always include a key that describes how the stem and leaf work together to create a number. It's very important. Next, I want to talk to you about variance, which is defined as s squared. S is your average distance from the mean. It's also known as your standard deviation, which, if you remember correctly, is one of our measures of spread. So variance is easily defined as just the standard deviation squared. So variance, the formula for variance, is equal to the sum of your terms of x minus the mean, squared over n minus 1. Or your standard deviation is equal to the square root of your variance. Standard deviation is also denoted as sigma. Transforming your standard deviation is very interesting. Two ways of transforming are adding a or multiplying by b, but you will find that adding a does not in fact affect your standard deviation. When writing how to transform standard deviation, you use variance. So variance is equal to b squared times sigma squared, or since it's all squared, it's very easy to take your square root and say that sigma, or standard deviation, is equal to b times your original standard deviation. Resistant versus non-resistant. This mainly requires your mean and median. Resistance defined as not being affected by outliers. So if I have this stem and leaf plot right here, your mean is going to be probably about 27. Your median here is 27.5. It's between 27 and 28. Now, if I erase that last term and change it to 49, which is an outlier, my mean increases to approximately 34 or something like that. But your median stays the same. Therefore, your median resistant and your mean is not. Comparing distributions. You can use a double stem plot or a double box plot. Double stem plot is just you got your stem in the middle and the leaves coming off of both sides, like so. Double box plot is you just put two box plots right on top of each other. Isn't statistics fun?